in a rectangle, you can see that all of the properties that go along with the parallelogram are listed right here, because all these properties apply to rectangles as well as two other properties. All four angles are right angles, as well as diagonals are congruent. So in this case, diagonals are congruent and they bisect each other. So their pieces of the diagonal are congruent. Okay. So the first example, A, we're just labeling and identifying what we know. So if EC, that's the same as AE, which is 15. DE, again, is also 15, because this equals this. So each one of these is congruent. So they're all 15. Now BE, again, is 15. AB, that is an opposite side to DC, which is 27. Opposite sides are congruent. It is really important to reference these constantly. So for B, QR is 10. SR is 24. PT is going to be 14, since all the ones here are congruent. QT is also 14. In letter C, it says important. The diagonals create isosceles triangles. Isosceles triangles have two congruent sides and the base angles are congruent. Alright, so first of all, in this particular isosceles triangle, these are my two congruent pieces, or legs, which means that these two angles are the same. Okay? That also applies here, because this isosceles triangle is congruent to this isosceles triangle. And in the past, we talked about congruent triangles and congruent figures, and we know that all angles and all sides are congruent to each other. Okay? Also, these two longer skinny triangles, these are isosceles because this one and this one are congruent, and this side are congruent, and those create base angles here. So these are the same, makes these the same. So now, if I have to figure out these different measurements here, let me erase all this. And it says the measure of XWY. Okay, so this right here. Well, I can figure this out because if a triangle has 180 degrees and these are congruent, we take 180 minus 64. If I subtract those, I get 116. So these added together give me the 116. I then divide that by 2 to get two equal angles, which is 58 degrees. So now I know that this is 58 and this is 58. And so are these down there. They're both 58, and then vertical angles makes this 64. Okay, now I've got to find the measure of Y, X, Z. So I'm looking at this one right here. And I can figure this out because I know that any angle, like a corner angle of a rectangle, is 90. So this is 90. So 90 minus that 58 gives me 32. So these right here are 32. Then the measure of WVZ. So this right here. And again, like earlier we took this in another day of notes. These are supplementary. Okay, so 180 subtract the 64 gives me that angle. So if I subtract those, we get 116. And so I know that this angle here is 116 degrees. Okay, then we have X, W, Z. X, W, Z. Again, that's a 90-degree angle. And then X, Z, Y. So we're looking at X, Z, Y right here. And remember, that's the same as these up here, which are 58. Okay. Letter D, it says, Bear is a rectangle, find the following. Alright, so let's start here with EAR, the measure of angle EAR. So EAR, so this, that's 90 degrees. Okay, we have EAB, so right here. Okay, now, this one, if you look, you see this triangle right here? It's the same as this triangle right here, okay? If this up here is already 70, then this is also 70. Okay, as well as this and this. These are all 70. Then we have EBA. Okay, EBA is this angle right here. This angle is 90 minus that 70, which is 20. Okay, now it says we need to find the measure of BT. So first, I got to find the measure of X. And so I'm going to say 3x minus 16 equals my other part of the diagonal, which is 6x minus 55. If I subtract 3, I get 3x. And if I add 55, I do get 39. So x is 13. But it asks for the segment length of BT. And BT is going to be that whole part. So I take the 13 and I plug it into this expression. So I would say 3 times 13 minus 16. And if I work that out, I get 39 minus 16, which is 23. So it's saying that this whole length is 23. But then it asked me for BA. So BA is the entire segment, the entire diagonal. So 23 plus 23 is 46.